speed and distance and learn how to solve the problems if it is asked based on the topic speed and distance. So first, let me give the formula to solve the problem. Speed, which is equal to distance by time. Here the distance is expressed in kilometer and time is always expressed in second. The unit of speed is kilometer per hour. Now by knowing the speed and time, how to find the distance? Now distance is equal to speed into time. The distance is always expressed in kilometer. And to find the time by knowing distance and speed, the formula is time, which is equal to distance by speed. And the next is how to convert the kilometer per hour to meter per second. Here x kilometer per hour, which is equal to x into 5 by 18. Here a kilometer is converted into meter per second. Here 1000 kilometers makes 1 kilometer. 3600 seconds it makes 1 hour. So now multiplying with 1000 divided by 3600, we get 5 by 18. So on multiplying x into 5 by 18, kilometer per hour is converted into meter per second. And now to convert meter per second to kilometer per hour, we need to multiply the x into the reciprocal of this 5 by 18, that is 18 by 5. So we can express the meter per second in terms of kilometer per hour by multiplying with this constant. And the next hint is if the speed or the ratio A is to B, then the time taken to cover the distance will be B is to A. Here the speed and the time are in the ratio opposite to each other. And the next formula is to find the average speed. Average speed, which is equal to 2xy divided by x plus y. Let x be the speed of one object and y be the speed of another object. So the average speed is given as 2xy divided by x plus y. Now in this picture, let us consider one object which is moving in the speed u and another object which is moving with the speed v. If the two objects are moving in the opposite to each other, then the average speed is given by adding these speeds, that is u plus v. And next, if the object are moving in the same direction, if one object is moving with the speed u and another object is moving with the speed v, then their average speed is given by subtracting their speeds, let it be u minus v. Now I given the basic formula to solve the problems. Let me tell how to solve the problem by applying all these formulae. Now the first problem is a person crosses a 600-meter long street in 5 minutes. What is its speed in kilometer per hour? The options are 3.6, 7.2 and 8.4 and 10. Here they are given the distance, it is expressed in meter, and the time it is expressed in minutes. Now first we have to find the speed by using the distance and time. Now speed is equal to distance by time. By using this formula, the distance is 600 divided by the time is 5, and to convert into seconds, it is multiplied by the 60. So 600 divided by 5 into 60, which is equal to 2 meter per second. Now we get the speed in terms of meter per second. It is 2 meter per second. On multiplying with 18 by 5, we can convert meter per second into kilometer per hour. So here the answer option B is the right answer. 7.2 kilometer per hour. So the person crosses in 7.2 kilometer per hour. Now the second problem, if a person walks at 14 kilometer per hour, instead of 10 kilometer per hour, he would walk 20 kilometer more. See, actually the person is moving with the speed 10 kilometer per hour. If a person walks at 14 kilometer, if he walks at the speed, he will walk 20 kilometer more. We need to find the actual distance traveled by the person. The options are 50 kilometer, 70 kilometer, 56 kilometer and 80 kilometer. From the options we have to choose the answer. Let me tell the solution to solve this problem. Here we'll be applying the formula distance divided by speed. See, let the distance traveled by the person, let it be x. Now x divided by the speed, that is x by the actual speed is 10 kilometer per hour, which is equal to the person would have walked 20 kilometer more. So we have to add 20 with the actual distance x. So x plus 20 divided by the speed is 14 kilometer per hour. Now we get the equation as 14x, which is equal to 10x plus 200. Now 4x, that is the 10x is taken to the left hand side. We get 4x, which is equal to 200. Now the answer is x is equal to 50 kilometer. So here the actual distance traveled by the person is 50 kilometer. But if he walks at the speed 14 kilometer per hour, he'd have walked 20 kilometer more. Then the distance would be the 70 kilometer. But the actual distance traveled by the person is 50 kilometer. Now move on to the third problem. A boy goes to his school from his house at a speed of 3 kilometer per hour and returns at a speed of 2 kilometer per hour. If he takes 5 hours in going and coming, the distance between his house and the school. See the question, the total timing to go and come to his house, it is 5 hours. See, the boy is walking at a speed 3 kilometer per hour to the school, and he returns at a speed of 2 kilometer per hour from the school to his house. We need to calculate the one-way distance, that is distance between his house and the school. The one direction we need to calculate. And the options here, it is 4.5 kilometer, 5.5 kilometer, 6 kilometer and 7 kilometer. The formula here will be using the average speed of the boy. Now average speed is given by the formula 2xy divided by x plus y. Now let x be the distance of a boy moving from his house to the school, that is 3 kilometer per hour. And y be the speed of a boy who moves from school to the house. Let it be 2 kilometer per hour. Now by substituting x and y value, we will get 2 into 3 into 2 divided by 3 plus 2, which is equal to 12 divided by 5. Now the distance traveled, which is equal to 12 by 5, it must be multiplied with 5, which is equal to 12 kilometer. Now the distance traveled, which is equal to 12 kilometer. Actually this is the distance on both the way. Now the distance between his house and the school, it is given by 12 by 2, which is equal to 6 kilometer. Yeah, the distance between the house and the school is 6 kilometer. Now the fourth problem is, a man complete a journey in 10 hours. He travels first half of the journey at the rate of 21 kilometer per hour and second half at the rate of 24 kilometer per hour. We need to find the total journey in kilometer. See, in this question, they are given the complete journey hour as 10 hours. He travels first half of the journey. They are given the speed. First of speed it is given and the second of speed it is given. We need to find the total journey in kilometer. The options are 220 kilometer, 224 kilometer, 230 kilometer and 234 kilometer. Here, see here, x is, let it be the total journey. So let the distance, keep it as x. Now by x, half of the journey they are given as 21 kilometer per hour. Actually in the numerator, x by 2 divided by 21 plus x by 2 divided by 24, which is equal to 10 hours. The 2x by 2 on the left hand side, that is taken to the right hand side. So the 10, it becomes 20. Now we get the equation as x by 21 plus x by 24, which is equal to 20. On taking the LCM of 21 and 24, we get the number as 168. So in the numerator, it will be 7x plus 8x, totally 15x on the left hand side, which is equal to 160 is taken to the along with the right hand side term. So 15x, which is equal to 168 into 20. Now on solving this equation, we get x is equal to 224 kilometer. Now the total journey for a man to complete in 10 hours is given as 224 kilometer. Now option A is the right answer. Coming to the fifth problem, excluding stoppages, the speed of a bus is 54 kilometer per hour, and including stoppages, it is 45 kilometer per hour. For how many minutes does a bus stop per hour? We need to calculate the how many minutes does a bus stop per hour. See, excluding stoppages, they are given the speed of a bus, that is 54. And including stoppages, the speed is given as 45 kilometer per hour. We need to find the difference between the speed of a bus, excluding stoppages with the including stoppages. On finding the difference, we get 54 minus 45, then the difference is 9 kilometer. Now 9 divided by the speed of a bus, excluding the stoppages, it is given as 54. This must be multiplied with the 60, because here we need to calculate how many minutes. In minutes we need to calculate. So hours, it is converted into minutes. So here 9 by 54 into 60, which is equal to 10 minutes. So the answer here, the bus stop per hour, it is in 10 minutes. Here the option B is the right answer. Now moving to the sixth problem, in a flight of 600 kilometers, an aircraft was slowed down due to bad weather. Its average speed for the trip was reduced by 200 kilometers per hour, and the time of flight increased by 30 minutes. The duration of the flight, we need to calculate the total time duration of the flight. Here in the question they mention the distance, and here the question they given the average speed for the trip was reduced by 200 kilometer per hour, and the time of flight increased by 30 minutes. The time is increased if the average speed for the trip was reduced by 200 kilometer per hour. Let us discuss the solution in detail. Here the distance divided by the time. Here the distance, it is 600 divided by, now the x, let it be the time. Now 600 divided by x plus 600 divided by, actually here the denominator is x plus 1 by 2, because the flight increased by 30 minutes. That's why increased by 30 minutes, half an hour. So x plus 1 by 2, that's why it is written as 2x plus 1 in the second term denominator. So 600 by x plus 600 divided by 2x plus 1, which is equal to 200. Now on solving this, we get the equation as solution of this equation is 2x plus 3 into x minus 1, which is equal to 3. Now we can neglect the negative value, because here 2x plus 3, here we'll be getting the x in terms of negative. Negative can be neglected. We'll be taking only the positive value. So x is equal to 1 hour is the right answer. So here the flight duration of the flight is 1 hour. Now I'll move on to the seventh problem. Here a man takes 5 hours 45 minutes in walking to a certain place and riding back. He would have gained 2 hours by riding both the ways. The time he would take to walk both the ways. We need to find the time which is taken to walk both the ways. See here, a man takes 5 hours 45 minutes on walking to certain place and coming back by riding. Now let us take the distance be x kilometer. Here I'll give you the first equation as time taken to walk 6 kilometer plus time taken to ride x kilometer is nothing but 5 hours 45 minutes. It is converted into a proper fraction. So 545 by 60, on solving this we get 23 by 4 hours. So time taken to walk x kilometer plus time taken to ride x kilometer, which is equal to 23 by 4 hours. Now time taken to walk 2x kilometer plus time taken to ride both the ways, that is 2x kilometer. We need to multiply 2 on the right hand side term. So 23 by 4 into 2, we get the answer as 23 by 2 hours. Now here we have the two equations. Now, but time taken to ride 2x kilometer, which is equal to 15 by 4 hours. Why I'm using this means, see here, you'd have gained 2 hours by riding both the ways. So you'd have gained 2 hours by riding on both the ways. By using that way, so here it is given as 23 by 2. So by time, which is given as 15 by 4 hours. By means you'd have gained 2 hours by riding both the ways. So I'm subtracting with the total hours minus the 2. That is 23 by 4 minus 2. So we get thus 15 by 4 hours. In the numerator, it will be 23 minus 8 divided by 4. 23 minus 8, it is 15 divided by 4. So time taken to ride 2x kilometer is equal to 15 by 4 hours. So therefore, the time taken to walk 2x kilometer. Now, to walk 2x kilometer means to ride 2x kilometers 15 by 4. That is taken with the right hand side term. So to walk 2x kilometer, which is equal to 23 by 2 minus 15 by 4. On solving, we get 31 by 4 hours. So this is converted into improper fraction. We'll be getting the answer as 7 hours 45 minutes. So here this hours, it is converted into minutes. So 745 by 60 is nothing but 31 by 4 hours. Now the answer that is he would take to walk both the ways. The time is 7 hours and 45 minutes. Let us move on to the next problem. A car travels 8 kilometers in the first quarter of an hour, 6 kilometers in the second quarter, and 16 kilometers in the third quarter. The average speed of the car in kilometer per hour for the entire journey we need to calculate. Actually, we need to find the average speed of the car in kilometer per hour for the entire journey. The options are 30, 40, or 36 or 24. We need to find the average speed in terms of kilometer per hour. The average speed is given by the formula total distance divided by total time. Here the total distance is nothing but we need to add all the distance which is given in the form in the equation. So here 8 plus 6 plus 16. Now the total distance is nothing but 30. And the total time here, first quarter of an hour. So quarter of an hour is nothing but 15 minutes. So 15 plus 15 plus 15. So we get 45 minutes. 45 minutes divided by 60. See, the minutes it is to convert it, we have to divide by 60, or else to find the average speed, which is equal to the total distance is 30 divided by, write the minutes as minutes, multiply on doing the multiplication with the 60, we can express the minutes in terms of hour. So in the speed formula, 30 divided by 45, do this into 60, we get the answer as 40 kilometer per hour. So the average speed of the car for the entire journey, it is 40 kilometer per hour. Let us move on to the next problem. The ninth problem. A tourist covers half of the journey by train at 60 km per hour, half of the remainder by bus at 30 km per hour, and the rest by cycle 10 km per hour. Then the average speed of the tourist in kilometer per hour during his entire journey. The options are 38, 30, 36, 24. See, the question, they are given the speed at different distance. So 60 km per hour, 30 km per hour, and 10 km per hour. We need to find the average speed. They are given the distance. See, they are given only the speed. So let us take the speed total distance as x. Now on taking x in the numerator, total distance is x whole divided by. See, in the question, just read the first sentence. A tourist covers half of the journey. So if the total distance is x, half of the journey means half of the distance, let it be x by 2. So that x by 2 divided by here with the speed 60 km. So in the denominator, total distance by total time. In that total time, it is expressed as time is equal to distance divided by the speed. So x by 2 divided by 60 plus, and here in the second sentence, half of the remainder by bus. So half of the remainder means 1/4 distance by bus and 1/4 distance by cycle. So y x by 4 divided by the speed is 30 plus x by 4 divided by 10 by cycle. So here x total divided by half of the distance divided by the speed, that is nothing but the time. Then again quarter of the distance with the speed 30 and quarter of the distance with the speed 10. Now on simplifying this, in the denominator we get totally 5x divided by 120. Now we get 120x divided by 5x. Now x get cancelled and 1 5s are, yeah, 24 5s are 120. Now the average speed of the tourist for his entire journey is 24 kilometer per hour. Now the option D is the right answer. And the 10th problem is, if a person walks at 14 kilometer per hour instead of 10 kilometer per hour, either walk 20 kilometer more, the actual distance we need to calculate, which is traveled by the person. See here, the total distance, let it be x. Now it is given by the equation x by 10, which is equal to x plus 20 divided by 14. That is, you know, walk 20 kilometer more means we need to add the 20 with the x divided by the actual distance. It is actual speed, it is given as 10, but if he walks at a speed 14 kilometer, you would have gained 20. So on the right hand side, it is given by the equation x plus 20 divided by 14. The total distance is 50 kilometer. And the 11th problem here, a man travels first 160 kilometer at 64 kilometer per hour and next 160 kilometer at 80 kilometer per hour. We need to find the average speed for 320 kilometer. See, the options are 35.55, 36 or 71.11 or 71. See, to find this average speed, here will be using the distance divided by the speed. So here a man travels first 160 kilometer at 64 kilometer per hour. So distance divided by speed, which is equal to with the time. So 160 divided by 64 plus 160 divided by 80, which is equal to the time, which is given as 9 by 2. Because here the question they mentioned, a man travels the next start 80 kilometer per hour. See here, they mention only that speed. So here 160 divided by 64 plus 160 divided by 80. And solving this, we get as 9 by 2. And so just we need to do only the distance divided by speed. The first 160 kilometer and the remaining 160 kilometer. We are taking the total distance as 160 divided by the speed. Finally, on solving this equation, we get 9 by 2. On simplifying 9 by 2, we get the answer in decimal, that is 71.11 kilometer per hour. This was the average speed for 320 kilometer. The 12th problem, in covering distance of 30 kilometer, Abhay takes 2 hours more than the Samir. If Abhay doubles the speed, then he would take 1 hour less than Samir. Abhay's speed, we need to calculate the Abhay's speed. See, in covering a certain distance of 30 kilometer, the total distance here is taken as 30 kilometer. Abhay, he takes 2 hours more than Samir. If Abhay doubles his speed, then you take 1 hour less than Samir. See, Abhay's, let us take the Abhay speed be x kilometer per hour. Now the distance is 30. 30 divided by x minus 30 divided by, here we are taking the Abhay speed as x. So when he doubles speed means then it is 2x. So 30 by x minus 30 divided by 2x, which is equal to 3. See here, on solving this, we get the equation 6x is equal to 30. Finally, x is equal to 5 kilometer. So here the distance is 5 kilometer. So we need to find the base speed. So here the base speed is taken as x kilometer per hour. Finally, we get the x as 5 kilometer. Now, a base speed, it is expressed as 5 kilometers. Now let us discuss few more problems. See, we discussed all these problems. The fourth problem is over. 6, a man completes. Okay, we'll choose a formula with the ratio problem. See here, the question number 8. The ratio between the speeds of two trains is 7:8. If the second train runs 400 km in 4 hours, then the speed of the first train we need to calculate. See, let us take the speed of two trains be 7x and 8x km per hour. If the second train 400 km in 4 hours, now it is expressed in ratio, that is 7, 8. So if they are talking about the second train, so speed 8x, which is equal to, speed is equal to distance by time. So 8x is equal to 400 divided by 4, which is equal to 100. From this, x is equal to 12.5. Now we get the x as 12.5. Now we need to find the speed of the first train. First train is given by the ratio 7x. So 7 into 12.5. We get the speed of the first train as 87.5 km per hour. And the next is a car traveling with 5/7 of its actual speed covers 42 km in 1 hour 40 minutes and 48 seconds. We need to calculate the actual speed of the car. The options are given. Now the time, let me explain the solution of this. Here the time taken is 1 hour 40 minutes and 48 seconds. It is converted into total hours. See here. Here it is nothing but 48 seconds. It is expressed as 4 by 5. So 1 hour, your 40 minutes and 48 seconds, it is converted as 4 by 5. And again, that is 48 divided by 60. First we have to do. And the second next, we'll be getting 44 by 5. And taking the proper fraction of 4 by 5 is 204 divided by 5, and again that is multiplied by the 60. See, each time we have to 48 by 60 first, then we'll be getting this improper fraction. Again, this whatever we are getting, no, that again we have to do it for a minute. So 40 divided by 60. So on doing, we get 1 hour 151 by 75 hours. And now totally converting this improper fraction to a proper fraction. 75 into 1 plus 51, it is 126 divided by 75 hours. So here the time taken is, first we have to convert into hours, and next let the actual speed be x kilometer per hour. Then 5 by x, 5 by 7 x into the time is 126 by 7, which is equal to 42. Why here we are using 42? In the question it is given as a car traveling 5 by 7 of its actual speed covers 42 km. So the distance which is equal to 42 km. So here the distance it is given as 42. which is equal to the 5/7 of the speed. Actual speed is taken as x kilometer per hour, and here 5/7 of into the x into the time. So distance into, sorry, here 5 speed into the time, which is equal to the distance. We are using the formula distance is equal to speed into time. All right, okay, now on simplifying this, we get the value of x, that is 75 into 7 we have to do first, and next 126 into 5, that is 42 into 7 into 75 divided by 5 into 126. First, what they did means 5/7 into x. We have to take this number to the right hand side, that it is 42 into 75 divided by 126. And again, the 5/7 is taken to the right hand side, then it is x is equal to 42 into 75 into 7 divided by 5 into 126. So we have to take all the numbers to the right hand side, keeping x in one side, that is left hand side. On simplifying this, we get 35 kilometer per hour. So here the actual speed is 35 kilometer per hour. See, if this is given as ratio 5/7 of its actual speed. If we are taking actual speed as x means, and then the 5/7 of the actual speed means 5/7 into x. And again, I'll tell this how to convert this into total hours if it is expressed in minutes and seconds. First, we have to divide 48 by 60 first, and again we have to convert into a proper fraction, and next 40 divided by 60. So each time we have to we'll be getting an improper fraction, we'll be converting into a proper fraction. Finally, we get the total time in terms of hours. And the next is, Robert is traveling on a cycle and has calculated to reach point A at 2 p.m. If he travels at 10 km per hour, he will reach there at 12 noon. If he travels at 15 km per hour, at what speed must be traveled to reach A at 1 p.m. See, Robert, he is traveling on a cycle and has calculated to reach point A. See, while he is traveling on the cycle, and he calculated to reach a point at 2 p.m. But if he travels at 10 km per hour, means he will reach there. If he is moving with the speed 10 km per hour, means he would have reached 12 noon, so 2 hours before itself. If he travels at 15 km per hour, if he moves with the speed 15, means we need to find at what speed. If he travels at 15 kilometers, see, he will reach there at 12 noon if he travels at. See, let me explain the question in detail. If he goes in a cycle and he calculated, if it travels at 10 km per hour, he will reach the point at 2 p.m. If the speed is 10 km per hour, means he will reach the point. He will reach the point at 12 noon if he moves with the speed 15 km per hour. See, 10 km per hour means the time is 2. If 15 km per hour means the time is 12 noon, 2 hours before. If he increases speed 5 km per hour. Now we need to calculate the speed when he reaches there at 1 p.m. Now let me explain the solution. The distance traveled by x kilometer. Let the distance traveled by the person, let it be x kilometer. Now x divided by the 10, that is the distance divided by the speed, minus distance divided by the speed is 15 km per hour, means first he said when he's moving with the speed 10 means the time will be 2, and if he's moving with the speed 15 means the time is 12. So time difference is 2. Now x by 10 minus x by 15, which is equal to 2. By using this, we get the equation as 3x minus 2x, which is equal to 16. Right? And now x is equal to 60 kilometer. Now we get the distance traveled by the person is x kilometer, and we need to find the required speed for this. So time taken to travel 60 kilometer at 10 kilometer per hour means then it is 60 distance divided by speed, which is equal to 6 hours we are getting. So Robert started 6 hours before 2 p.m. that is at 8 AM. So he need to take 6 hours to travel 60 kilometer at the speed 10 kilometer per hour. So we need to find required speed, which is equal to the distance is 60 divided by 5, which is equal, speed is equal to distance divided by time, because 6 hours when the time is 2. And the question is, we need to find the required speed when there he reaches the time at 1. The time difference is 1 hour here. So 6 minus 1, so that we'll be taking the time as 5 in the denominator. Speed equal to distance. Distance is 60 kilometer. And the time here, what we are taking is 6 minus 1. So 5, 60 divided by 5, which is equal to 12 kilometer per hour. Okay, the next question is, it takes 8 hours for a 600 kilometer journey. If 120 kilometers is done by train and the rest by car, it takes 20 minutes more. If 200 kilometers done by train and the rest by car, the ratio of the speed to that cars is, we need to calculate this ratio of the speed of the train to that of the car. We need to find the ratio speed of the train and the speed of the car. Let us take the speed of the train be x kilometer per hour. The car be y kilometer per hour, then 120 it is a distance divided by speed of the train, that it be x plus 480 divided by speed of the car is y, then 120 divided by x plus 480 divided by y, which is equal to, see in the question they are given 20 minutes more. Here will be, it takes 8 hours. So the question they mentioned as 8 hours for 600 kilometer journey. So 120 distance means 600 minus 120 is 480 by a car. So 480 divided by y, the total timing is given as 8. Here the formula what we are using here is time. Time is equal to distance by speed. So on solving this, we get the equation is 1 by x plus 4 by y is equal to 1 by 15. And next, by using the next is 200 by x plus 400 by y, which is equal to 25. See, it takes 20 minutes more if 200 kilometer done by train and rest by car. So 200 means 600 minus 200 is 400. So 400 kilometer divided by y. The total time is given as 20 minutes. Now, by substituting that, we get the next second equation, 200 by x plus 400 by y, which is equal to 25 by 3. Now, here the equation is 1 by x plus 2 by y, which is equal to 1 by 24. Here, on solving the two equations, here we get y plus 4x, which is equal to xy by 15. Convert this, otherwise let us take 1 by x as capital X and 1 by y as capital Y. Keep it as capital X and capital Y and solve the equations. And here let me tell, see, capital X plus 4 capital, actually the capital X is taken as 1 by small x. Take the reciprocal of this, which is equal to 15. The same way you take this next equation. So two equations are solved algebraically. We'll be getting x as 60 and y as 80. Now the ratios of speeds of a train and the car is 60 is to 80. On simplifying it further, we get as 3 is to 4. And moving to the next problem. A farmer traveled a distance of 61 kilometers in 9 hours. He traveled partly on foot at 4 kilometers per hour and partly on bicycle at 9 kilometers per hour. The distance traveled on foot. We need to calculate the distance traveled only by the foot. Here, let me explain the solution. The distance traveled on foot be x kilometer. And now the distance traveled on bicycle, let it be, see, partly on bicycle means here let it be total distance is 61. If he is walking by foot is kept as x means Then the distance traveled on bicycle is taken as 61 minus x. Here we are using the formula time is equal to distance by speed. Your x divided by 4 plus 61 minus x divided by the speed is 9 kilometer, which is equal to total time they are given as 9 hours. So 9x plus 4 into 61 minus x divided by 36. That 36 is taken to the right hand side. So 9 into 36 we get on solving this equation, we get 5x is equal to 80. Finally, the answer x is equal to 16 kilometer. So here the distance taken by the farmer to move partly by the foot is 16 kilometer. So here the option C is the right answer. Now moving to the next. A man covered a certain distance at some speed. Had he moved 3 kilometers per hour faster, he would have taken 40 minutes less. If he had moved 2 kilometers per hour slower, he would have taken 40 minutes more. The distance we need to calculate. See, let us take the distance as x kilometer and usual rate as y kilometer per hour. So find the equation x divided by the speed minus x is a distance divided by, here in the first case the usual rate plus had he moved 3 kilometers per hour faster. So here we'll be doing the addition. So x by y minus x divided by y plus 3, which is equal to 40 minutes. It's converted in seconds, so 40 by 60. And simplifying this, we get the equation as 2y into y plus 3, which is equal to 9x. Now we can write the next frame, the next equation. Using the second hint is given. So total distance x divided by y minus 2. Why it is y minus 2 means if he had moved 2 kilometers slower. So x by y minus 2 minus x divided by y, which is equal to, if it have moved 2 kilometers per slower means it okay again it have 40 minutes more. So 40 divided by 60, which is equal to, we'll be getting the next equation. We have to solve these two equations. On solving, on dividing the 1 and 2, we get x is 40. So here the distance is 40. Now move on to the next problem. Two trains starts from P and Q respectively travel towards each other at a speed of 50 km per hour and 40 km per hour respectively. By the time they meet, the first train has traveled 100 km more than the second. The distance between P and Q. See, two trains, will be discussing about the two trains P and Q. Travel towards each other at a speed of 50 km per hour and 40 km per hour. The speed of the two train it is given, and by the time they meet, the first train has traveled 100 km more than the second. So the first train is moving the speed 50. So the first train has traveled 100 km more than the second train. Now we need to find the distance between P and Q, the distance between the two trains at the time of meeting. Like the distance traveled by the second train, let it be x kilometer. Then the distance covered by the first train is x plus 100. See, by taking the distance by the second train as x means, then distance by the first train is, because the first train moved 100 km more. So the distance by the first train, let it be x plus 100. Now x divided by the speed, that is a distance x divided by the speed, which is equal to the distance covered by the first train divided by its speed. So x plus 100 divided by 50. X by 40, which is equal to x plus 100 divided by 50. We get the equation as 50x, which is equal to 40x in plus 4000. So 50x, which is equal to 40x plus 4000. Now 50 minus 40x is taken to the left hand side. So 50 minus 40x is just 10x, which is equal to 4000. Finally, x is equal to 4000 divided by 10. Now x is equal to 400. Now this is what the distance traveled by the second train, that is 400 kilometer. And here the distance traveled by the second train q is equal to 400 kilometer. Now a distance, we need to calculate the distance between p and q. Actually, the first train is 400 plus 100 kilometers, right? So the first train is 500 kilometers. Now the distance between the two P and Q. See, already I said while I'm teaching the formula, the two trains are starting from the same point and they are traveling along the same direction. If they are moving along the same direction, we have to add the distance. So here the distance between the P and Q, it is given as 900 kilometer. If the two objects moving in the same direction, here you are just we add the distance as 400 plus 500. So the total distance between P and Q is given by 900 kilometers. Let's move on to the next problem. The two trains starting at the same time from two stations, 200 kilometers apart and going in opposite directions, cross each other at a distance of 110 kilometers from one of the stations. We need to find the ratio of their speeds. See, two trains starting at the same time from two stations apart and going in opposite directions, cross each other at a distance of 110 kilometers from one of the stations. See here, in the same time they cover 110 kilometer and 90 kilometer respectively. Now the ratio of their speeds is given as 110 is to 90, which is equal to 11 is to 9. The next is, see, A and B walk around a circular track. They start at 9 a.m. from the same point in the opposite directions. A and B walk at a speed of 2 rounds per hour and 3 rounds per hour respectively. How many times shall they cross each other before 9:30 a.m.? See here, the relative speed is equal to 2 plus 3, which is equal to 5 rounds per hour. A and B walk around a circular track. They start at 9 a.m. from the same point in the opposite direction. See, here the two persons A and B are moving in the opposite directions in a circular track. A and B walk at a speed of 2 rounds per hour and 3 rounds. See, A is moving at 2 rounds per hour and B is at a speed 3 rounds per hour respectively. How many times shall they cross each other before 9:30 a.m.? So within 30 minutes they are asking. So they cross each other 5 times in an hour. We have to add the relatives because both are moving in the opposite direction. Just add. So 2 plus 3, add the speeds, we'll be getting 5 rounds per hour. So they cross each other 5 times in an hour and 2 times in half an hour. Hence they cross each other 7 times. Totally they cross each other 5 times in an hour and 2 times in half an hour. 2 times in a half an hour. How many times shall they cross each other before 9:30 a.m.? So they cross each other 7 times before 9:30 a.m.